Let's start today with a warm-up. Find as many positive and negative coterminal angles you can with 5 pi over 4. Pause the recording. I'd recommend 3 minutes to give yourself. Now that you've given yourself some time to find those coterminal angles, let's see what they are. I went ahead and found 2 positive and 2 negative. The thought process behind this would be, what kind of angle am I dealing with? This is radians. So back here, you should have realized this is not degrees. We're going to use radians. And just like we've learned before, if you want positive, you add 2 pi or increments of 2 pi. Because remember, there's an infinite number of positive and negative coterminal angles. You just keep going around the circle again and again and again. Remember, positive angles and coterminal angles are going clockwise, and then negative are going counterclockwise. But the idea is very similar. Here you're subtracting 2 pi and increments of 2 pi. Now what we're doing is adding and subtracting fractions, right? So you already know you need to multiply by a fancy form of 1 to get those common denominators. And there's our 2 positive and 2 negative coterminal angles. If you found more, kudos to you. If you found less, well, make sure you practice this and know how to do it. And my friends, today is the day we've been waiting for all unit to find out the rest of the information about what we see in the unit circle and finally see the unit circle and understand how it works. I've told you this before and I'll say it again now. I'll say it again when we see it. You're doing the heavy lifting now to understand why the unit circle is what it is and how it looks and what everything means. But when you get to it, the idea is that that's a tool now. You know how it works and you can answer questions by simply looking at it. Lesson goals, there are quite a few. I'm going to read through these, but just so you know, you've already done most of this in the past, whether it was in this unit or a geometry class. So determine the coordinates of the ordered pairs. So coordinates of ordered pairs on the unit circle that correspond to a given radian measure. Explain the relationship between the real numbers and the coordinates of the ordered pairs on the unit circle in terms of trig functions. Determine the exact trig functions with values for multiples of pi over 6, pi over 4, and pi over 3. Determine the exact values of expressions with trig functions by using the unit circle. Determine the quadrant in which the terminal side of an angle lies, given signs of its trig functions. And determine the sign of a trig function given the quadrant in which the terminal side lies. Let's get into it. We're going to do a little recap here so we refresh our memories on how the unit circle works. Remember, the unit circle has a radius of 1. Where's the radius? Well, it's a distance from the middle to the outside. It could be there, there, could even be here. Any place on the circle that's showing you the distance from the middle to the outside. Central angles in the unit circle. Central angles are in the center and they're measured in radians. Here we know radians love pi and we see these on the outside. Why are they on the outside though and not in the center if they're central angles? Well, we've talked about this before, right? If you were to cram all these in this little itty bitty space, it would be hard to read. So that's why we see them on the outside. Remember, you start at the initial side, which is right here. And if you're talking about positive radians, which is what we see here. You go in the positive direction, and one full time around the unit circle is 2 pi radians. Okay. Now, you're hopefully comfortable with radians and the central angles, so the focus is going to be learning about the coordinates, aka the ordered pairs. So we're talking about these points around the outside. Okay, so remember when you see the radians or degrees on the outside, these are not the points. These are not ordered pairs, right? We know ordered pairs look like this with an x, comma, y. That's what we're going to get into right now. So what about these points? Well, from any point on the unit circle, like this blue point we see here, you can draw a perpendicular line, right? A perpendicular vertical line to the x-axis, creating a right triangle. And we call this a reference triangle because we refer to it to find out what those points are. Okay? Now we're going to do this together right now, specifically to discover something very profound, very meaningful. But after we do, you're not going to need to find it every time. You're just going to need to know what it means. Okay? Well, we know the hypotenuse is the same as the radius. It's a unit circle, so it's 1, right? Now, we're going to use this diagram to find the cosine and sine. Give yourself a chance right now to find that on your own. Cosine is ca adjacent over hypotenuse, and this is theta. So since we're dealing with theta, we don't know the angle, right? So remember a moment ago I said this is pretty profound, and here's why. What you're about to find is true not just for a specific angle, but any angle. In this case, theta is unknown. That's the angle we care about, that central angle. And the adjacent side is going to be between the angle we care about and the right angle. So we have x over 1, which is just x, and sine, so, is opposite the angle we care about, right? Y over hypotenuse 1, so y. Do you realize what you just figured out? Here's what it is. The cosine of any angle is equal to the x value of the point. Right there. The cosine of this angle is the same as that value. So if you're asked, what's the cosine of this angle, when you have a question, or you're going to actually know the angle, you're going to just say whatever that x value is. Okay? And very similarly, sometimes you'll be asked, what's the sine of this angle? Well, we just found the sine of any angle is the y value. So go ahead and write down what's in this yellow box. The cosine of the central angle will always be the x coordinate, and the sine of the central angle will always be the y coordinate. Cosine goes with the, excuse me, cosine goes with x, sine goes with y. Cosine x, sine y, it's both alphabetical too, right? C comes before s, x comes before y. And the beauty in this is when you're asked this, you don't need to figure out. You don't need to work out SOHCAHTOA. You should just hopefully know that's the cosine, that's the sine. So let's go ahead and learn a little bit more about triangles you've seen before, and then we're going to practice some questions about what we just learned. Okay, there's a quick review from geometry. Two of the most popular triangles that exist are 45, 45, 90 and 30, 60, 90 because you see them the most in the real world. So it's important to know how their sides correlate. For a 45, 45, 90, these two sides are the same. The hypotenuse is that length times pi over 2. For 30, 60, 90, It's all in relation to x, right? So the side between the right angle and 60 degrees is going to be half of the hypotenuse. And then the other side is going to be this side that's not the hypotenuse times square root of 3. That's a little review. Now let's take a look at it on the unit circle. Again, the three sides relate, and here's how they relate. And the only thing we really know first and foremost is the radius because it's a unit circle, right? And these sides, how do they relate? Well, if this is times square root of 2, these have to be that not being times square root of 2. So that would be square root of 2 over 2, square root of 2 over 2. You don't need to figure this out. Just know that for the unit circle, for a 45-degree angle, this is your ordered pair. And they're both positive because why? They're in quadrant 1, right? You go right in the positive direction, and then you go up. Positive direction, positive, positive, just like any ordered pair in quadrant 1. Now, I told you I was going to ask you this a moment ago, so here it is. What's the cosine of this angle? Hopefully you said this value right here. No work needs to be done. We just learned that the cosine of any central angle is the x value of that ordered pair. How many 45, 45, 90 triangles do you think there are on the unit circle? Well, here we only see one in quadrant 1. We also know it's a 45-degree angle, so there's going to be 4. Okay? Take a quick look. Here's the 45 degrees, right? Here's the right angle. Well, if you continue to draw that line down, and I think these lines are out of place. There they are. Let's that a little more lined up. Okay. So there's one. Here's another. Let's put that right angle box in the right place. Oh, 1 second. Here we go. There we go. All right. So we see the two on the left, on the right, and the same things are going to happen on the left. What do you notice that's interesting about all of these points? They have something in common, don't they? But they also have something different, right? Remember, any point on any graph in quadrant 1 has a positive x, positive y. Quadrant 2 always has a negative x, positive y. Quadrant 3, both are negative. And quadrant 4, x is positive, y is negative. That's why you see the sign changes. This also means that sine and cosine will always be positive in quadrant 1. Sine will be negative or positive in quadrant 2. Neither will be positive in quadrant 3, and then cosine positive quadrant 4. You will be asked questions about that, but I have a more visual diagram for you on that in just a moment. Now, let's take a look at the 30, 60, 90 triangle on the unit circle. Again, we have the three sides correlating, all in relation to the radius of 1. So this side is going to be half of that, right? And then this side is going to be that times square root of 3. We see that there. Okay. So we have all the measurements we need. And for 30, 60, 90, these are the coordinates. Okay. What is the sine of 30 degrees? Remember, 30 degrees is the central angle, the one we really care about. And the y value of the ordered pair is the sine. So 1/2 is the answer. How many of these do you feel there are on the unit circle? Well, you might be thinking four again, because there were four with the 45, 45, 90, but not quite, because these triangles are a little slimmer. There's actually two in each quadrant. Let's break it down. So here you have your right angle, and here's the 60-degree angle. Here's the 30. And of course, you can extend this down. Here's another right triangle. Of course, this would be the 60. This would be the 30, right? And then you're going to have that as well over here. Then you're going to have your other triangles, the shorter ones, I would say, right here, where here's the 30, here's your 90, and there's your 60. And then, of course, same thing below. Okay, you're going to see two unit circles. One will have those triangles on it to help you, the other will not. Are we ready? Finally, time to see it. Here it is, the unit circle with all of the information. And that's exactly what it is. Information. It looks like a lot, and it is, because it's there to help you. This is your friend. You've been working up to this point to understand what this is and how it works. At this point, hopefully you do understand how it works, and you can just really look at it to figure out what the answers are to the questions you're asked. So let's start asking some questions. What type of information are these values out here? Those are your ordered pairs, right? Of the points of this and this and this. These are your ordered pairs of these points that go around the most popular angles of the unit circle, right? They go all the way around. Okay, let's do another. What information is this? Those are your radians, right? And remember, radians, if you go around one full time, there are 2 pi radians in your unit circle. Last but not least, what are those? Those are degrees, right? And if you go around one full time, there are 360 degrees in a circle, in any circle, and the unit circle is no exception. So that is the information. At this point, you can screenshot this. You can access this in the recordings document. You can Google your own, however you want to access the unit circle. But my advice to you is have one handy. You might want to even print it out. Maybe that's the most useful way to do this. Okay. Here's another version I told you I'd share, just showing those congruent triangles. And I mentioned this earlier, but here is a visual and a way to remember the values that are positive and negative. Okay? If you look at the sign, each quadrant, what do they all have in common? Well, all of these values say greater than zero. What does greater than zero mean, though? It means they're positive, right? So we're talking about the ordered pairs and we're talking about the sine, cosine, and tangent. So in quadrant one, everything is greater than zero, the x, the y, all of that, all positive. In quadrant two, the sine, aka the y value of the ordered pair, is positive. Quadrant three, we didn't really talk about tangent, but the tangent will be positive in quadrant three. And cosine, which is also the x value, will be positive. Okay, so this is another useful bit of information. If you want to maybe come up with a saying, remember we go through the quadrants like this, 1, 2, 3, 4. Maybe you want to say add sugar to coffee. Or you might want to come up with your own saying to help you remember, but this is going to help you with some questions you're asked. And speaking of questions, are we ready to practice answering some to get you ready for the 7.06 quiz? If not, rewind this, pause it, study it more, and once you are, we're going to do this together. Some practice problems for you. Here's number one. At what point does the terminal side of the angle 4 pi over 3 in standard position intersect the unit circle? This is a very wordy question. I'm going to give you a moment to work it out. Okay, let's see how you did. It says, at what point? So we're looking for a point. That's what our answer is going to be. It's not going to be an angle, radian or degree. It's going to be a point on the outside. Okay. At what point does the terminal side of the angle, so this is very wordy, terminal side of the angle 4 pi over 3 in standard position intersect the unit circle? That is very wordy. Remember, this is really all that it means. Where did my line go? I'm adding a line here so we can really visualize this. Give me 1 second. Okay. And I'm going to change the color actually so it's easy to see. Here we go. So we always start at the initial side, right? And then this is a positive radian, so we're going to go in the positive direction, which is counterclockwise. So they're saying, when they say standard position, they're just saying we're talking about a unit circle, we're starting at the terminal side, and we're going around until we find that angle. So we're going to go around, tick, 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 all the way until we find 4 pi over 3. Boom, there it is, right? There's 4 pi over 3. So this is the initial side, this is the terminal side where we stopped, meaning the angle is going to be like this. We see that angle labeled there. Okay, more specifically, the angle is like this, right? It's all of this, but we just see it labeled right there because that's technically where it stops. Okay, so what's the point associated with that angle? It's right there. That's your answer. So do you see what I'm saying? How the unit circle is really your friend and a tool? There was really no work to show. I showed some work and explained it to help you. But if you know, oh, that means that's really asking me what point is associated with 4 pi over 3. You just look, find 4 pi over 3, boom. Circle the point. There it is. All right, number two. Which point on the unit circle corresponds to negative 5 pi over 6? Pay close attention to what the question's asking you as you work this out. Okay, let's go ahead and see what happened. The key element here to focus on is that negative sign. If you said, okay, 5 pi over 6, there's the answer, not so fast. This is positive 5 pi over 6. This is negative. So there's two ways to think about it. I'm going to show you. Okay. One way is to say, okay, I know if I travel in the positive direction, 5 pi over 6 is there. Okay, that's this line. So if I go in the negative direction, the same distance, okay, I'm going to be right here. So that tells me this point, which is the answer. That is the point. And that's one way to think about it. Another way to think about it is to go, okay, well, if I travel this far to get to 5 pi over 6, the negative 5 pi over 6 is immediately below. So if you draw that vertical line, boom, there's your negative version. Because technically, when you have the negative values, all of these, it flips, right? And these go down here. And then vice versa, right? All of these values on the bottom flip and they go up here. If you're talking about a negative graph. So I'm just trying to get you thinking in terms of how do I find those negative angles? All right, number 3, what is the exact value of the cosine of 2 pi over 3? Again, for all these, I encourage you to pause, give yourself a try. Again, this is a problem that's very quick if you know what you're looking for. You're finding the cosine of this positive radian. Well, no tricks with positive radians. You just look for it. 2 pi over 3 is right there. What's the cosine? We went over this several times today. It's the x value of that correlated with that angle. So negative 1/2. Okay, this one is going to be a bit more tricky. They want to know the exact value of the tangent of negative 7 pi over 4. We haven't really talked about tangent today, but we have throughout this unit, so you know what it is, you know how to find it. So let's figure this out. First you try. Okay, now let's do it together. What's the exact value of tangent negative 7 pi over 4? Okay, I need to first find where in the world that is. Where's positive 7 pi over 4? Right there. Look at that. If I'm going in the positive direction, I'm going nearly all the way around the circle. So there's the positive version. And remember, like we said a moment ago, to find the negative version, you just go directly above. So, okay, so we're right here. So there is negative 7 pi over 4. Now they want the tangent. Well, tangent is sine over cosine. So tangent of negative 7 pi over 4 is sine. Well, we learned that sine is the y value, didn't we? And cosine is the x value. It's true, it's true. We're dealing with a complex fraction. But lucky for us, we have the same exact value on top and bottom. If we didn't, how would we solve this? Because notice a lot of these, that's not the case, right? Where you don't have the same exact thing. Well, then you need to keep, change, flip, right? In other words, dividing fractions is the same as multiplying by the reciprocal, but we don't need to do all that because we know we have the same thing over itself, which is just equal to 1. And for the sake of you learning this and being prepared for quiz questions, I'm just going to also do the keep, change, flip. So keep the top fraction the same, change division to multiplication, flip the second fraction, and guess what? You could multiply these across. You could cross cancel. I'm going to cross cancel. 2 goes into 2 once. Square root of 2 goes into the square root of 2 once. You multiply everything across. You get 1 over 1, which is equal to 1. And last but not least, we have one more practice problem for you today. In which quadrant does theta lie? Does the unknown angle lie, given that sine is positive and cosine of the angle is positive. Hmm. You saw something helpful for this just a moment ago. And here's a heads up on your quiz. Read the inequality signs carefully. If it's greater than, less than, whatever it is. Okay? So sine and cosine are positive. Remember, that is all values in quadrant one, right? All of these have both, everything's positive, right? Everything, you don't see one negative sign there. So quadrant one. You did it. You learned about the unit circle. You have a quiz today to increase your understanding of it. Take a try, see how you do, and see what you need to maybe study. All right. I will see you next time.